Hello students. Welcome back to the channel Science Therapy, hosted by the one and only science therapist Abudiwa Sos Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have questions on analytical geometry. And this analytical geometry that we have here is compatible for both grade 11 and grade 12. So feel free to watch the video up until the end and learn very quick ways to tackle your analytical geometry questions. Let's go to it. So we have question 1.1 says determine the coordinates of M, the midpoint of AC. Right, so they're telling us that M is a midpoint of AC. That means if we just have to draw a line joining the points A to C, then the coordinates that we'll have at the center there would be the coordinates M, right? And then these are the coordinates that we are trying to get. So we know the midpoint formula, it goes M, and then x coordinate to the y coordinate is equals to x1 plus x2 over 2, and then y1 plus y2 over 2. So these are one of the formulas that you have to know when it comes to dealing with analytical geometry, because you'll be required to use it. So x1, we're going to have -3, and then x2, we're just going to put it as our x coordinate of C, and then that divided by 2. Then now we come to the y coordinates. We have 0 plus -1, and then all divided by 2. Then obviously at this point it's just a matter of using your calculator to find your values there. So we find that our values are -1 over 2 to -1 over 2. So these are the coordinates for M, and then looking at where M is, these coordinates do make sense. So the coordinates for M are -1 is 2 and -1, right? So just like that, we have calculated for 1.1. Then 1.2 says show that AC and BD bisect each other, right? So again, now they are saying that we have another line BD. So let's join points B and D, and then there we go. But then now we must prove that these two lines bisect each other. What is the meaning of the word bisect? Now we know bisect means cuts into equal halves. So you can say cuts into 2 equal halves, right? So in other words, we must prove that the line AC will bisect the line BD, and BD will also bisect line AC, right? So in other words, that means here, this is equal to that, and then this is equal to that, right? So now, if these lines bisect each other, that means they would have to do it at the same point there. So they would have to do it at this particular point. So how can we actually prove that AC and BD bisect each other? We can actually go about and also calculate the midpoint of BD. If we find that the midpoint of BD is the same coordinate, we are producing the same coordinates as with the midpoint of AC, then this actually proves that these two lines are actually bisecting each other. They cut each other into 2 equal halves, right? So okay, now let's go about it. So again, we're going to try to calculate the midpoint coordinates for BD this time around. So this is x1 plus x2 over 2, and then to y1 plus y2 over 2, right? Then let's use our x1 as the x coordinate of B, and then our x2 as the x coordinate of D, then divided by 2, and then our y1 is the y coordinate of B, and then our y2 is the y coordinate of D, then divided by 2. Now, if you punch in your calculator, you will see that here that's -1 over 2, and then also as well as this one, that's -1 over 2. So we just found the same coordinates, the same midpoint coordinates for both line AC and line BD, which will prove to us that BD and AC bisect each other. So our conclusion is that therefore BD and AC bisect each other. Why? Because they have the same midpoint, right? Then that's how you were supposed to tackle that one. Now let's move to 1.3. 1.3 says prove that ADC, so where is ADC? With ADC is 90 degrees, right? Now, how can we prove that one? Remember, the fact that ADC is 90 degree, we can look at it this way. If this here is forming 90 degrees, this tells us one thing about the lines AD and DC. That means line AD would have to be perpendicular to line DC for us to produce 90 degree there, right? So remember, when two lines meet perpendicularly, then obviously they produce an angle of 90 degrees. So the approach we would take here is to prove that line AD would be perpendicular to line DC. But how would we achieve that? We know of this rule that says if AD will be perpendicular to line DC, then that means the product of their gradients. So if I say gradient of AD multiplied by gradient of DC, then I have to produce -1. So now I can try to look at it using this approach. Then I'm just trying to prove that AD will be perpendicular to DC. That means if I calculate the gradient of AD and then I can calculate the gradient of DC, then multiply them together. If they give me -1, this would prove that the two lines are perpendicular. And if the two lines are perpendicular, this will tell me that the angle produced in that point of contact or in that point of intersection is 90 degrees. Okay, so now let's go. We have a gradient of AD, which we're going to say y2 minus y1 over x2 minus x1. So another important formula to note when dealing with analytical geometry, your gradient formula, right? So let's take our y2 as the coordinate of the y coordinate of D, and then our y1, the y coordinate of A. Then again, in that order, we take the x coordinate of D, subtracted by the x coordinate of A, right? Now at this point we have this will give us 2 over 3. So this is the gradient for AD. Okay, but now let's calculate the gradient for DC. So gradient of DC, again, y2 minus y1 over x2 minus x1, right? So if we follow the approach again, let's take the coordinate, the y coordinate of D there as our y2, and then the y coordinate of C as our y1. So minus -1, and then over, we take 0 as the x coordinate of D, and then -2. So minus, minus 2. And then what is 2 minus -1? That's positive 3 up there, but 0 minus 2, that's -2. So at the end of the day, we're going to have -3 over 2 as a whole, right? Now, looking at this 2 gradient, if we can then say the gradient of AD multiplied by the gradient of DC, let's see what they produce. So we have the gradient of AD as 2 over 3, then multiply it by the gradient of DC, which is -3 over 2. And then what is our product from multiplying the 2? Obviously, here we can see that the product is -1. And then now, since we have proven that the gradient of AD multiplied by the gradient of DC is equals to -1, this tells us that AD is perpendicular to DC. And if AD is perpendicular to DC, what do we know? That means angle ADC has to be 90 degrees, right? And just like that, you have answered that question for a total of 4 marks. So that's just how you were expected to go through that question there. So let's proceed. These are very nice questions. Then 1.4 says show that ABCD is a square, right? Now, what do we know about a square? The one property that we are all aware of when it comes to a square is that a square has all the sides equal, right? So if this is a square, then what we must prove is that AD here will just be equal to BC, and then DC here will also be equal to, in fact, all of the sides will be equal. So that's what we know about a square. All sides are equal, right? So if it was a rectangle, we'd say the two pairs of sides are equal. So this side would be equal to that side, and this side would be equal to that side. But since it's a square, one property that we know of a square is that all sides are equal, right? So we'd have to prove that all the sides are equal here. Okay, then but then obviously that would be very much a waste of time here, because looking at this diagram here, we can only suspect that if it is not a square, it's a rectangle, right? So in order to disprove, if I can put it that way, that it is not a rectangle, I would just go calculate side AD and then calculate side DC. If I find that side AD is equals to side DC, then this, without any shade of doubt, will prove to us that it is definitely not a rectangle. So obviously, if it is not a rectangle, then it has to be a square, right? So this is the approach that I'm going to take into answering that question. So first of all, another formula that is important, I'm going to use the distance formula, right? So distance formula, I'll go AD, and then I go root, and then this goes, the distance formula is x squared minus x1, x2 minus x1 square plus y2 minus y1 square, right? So pardon me for that. So that's how you go about it, right? So you say your x2 minus x1, and then inside the bracket square, plus y2 minus y1 inside the bracket square. So, okay, calculating for AD, so let's consider our coordinates there. So if we are using x2 as this one, that will be 0 minus -3, so which is minus, that's going to end up being plus. So then square that plus, and then the y coordinate for D is 2, and then minus 0, and then square, right? So if we punch all that into our calculator, the value that we end up with there is root 26, right? And then let's try to do it with DC. So if we do it with DC, again, we have root x2 minus x1, then square, plus y2 minus y1, and then square. So for our x2, remember, now we are considering a DC. So again, we can start with 0 minus 2. If we are taking our x2 as this one, and then our x1 as that one. Then our y2 here, we have 2. But then that's minus -1, which will just say minus, and minus, that's plus, and then square. Again, if we punch this into our calculator, we end up with root 26, right? So now that here we got root 26, and then here this is root 26, right? Observing from our diagram, we can obviously tell that this line here, AD, is equal to line BC. Right, so that's even root 26. And then we can also tell that DC here is equal to line AB. So this is also root 26. So this proves without any shade of doubt that we have a rectangle, right? So for the mere fact that all these lines here are equal, so your AD is equals to DC, which is equals to BC, which is equals to AB. So this proves that ABCD is a square. ABCD is a square, right? And then, okay. Let's proceed. So we have 1.5 says determine the size of theta, the angle of inclination, right? The angle of inclination. One thing about the angle of inclination, you must always note that whenever we are calculating our angle of inclination in maths, it always takes the anti-clockwise direction. So it's always from the x-axis and then to that specific line. And then the way we get the angle of inclination is always using this formula here, tan theta, right? So also another formula to note, tan theta is equals to to m. So that's tan theta is equals to the gradient. So the gradient that we choose to use is the gradient of the line where we see our angle being attached, right? So we can see this, that this angle here is forming in between the x-axis and this particular line DC. So that means that's the gradient that we'd have to calculate, and then therefore use that gradient in order to find our theta. So obviously we leave theta here as the subject of the formula, then transpose that tan as arctan, and then we calculate. So it's always like that. Also, another thing that I want you to note, if this was here, so let me try maybe to extend this line here. So the angle of inclination for this one here would be found here, right? So the angle of inclination would have to be somewhere here, right? So note that the angle of inclination always has to be between the x-axis and that particular line. So one thing that you have to check when calculating, if you observe that your angle of inclination is actually an obtuse angle, what you will notice with calculating is that when you calculate, most of the time you'll find your angle of inclination as an acute angle. But then if you observe that it's an obtuse angle, note that this angle here forms the angle on a straight line. So if you get an acute angle, then you just have to subtract this acute angle from 180 degrees so that you get the obtuse angle. So in most of the time, the reason you will find the acute angle is that it's because this one is actually a decreasing line, right? But then here you are calculating the angle of inclination, not the angle of depreciation. Gradient, we did calculate the gradient of DC back there in the question. So let's find the gradient of DC. So we had our gradient for DC as so let's say gradient of DC is negative 3/2. That's what we had. So obviously it's a negative gradient because this is a decreasing function. It's a decreasing line. Then we have tan theta. So here this tan theta is equals to the gradient of DC. But our gradient of DC is negative 3/2. So that means tan theta is equals to negative 3/2. So okay, so now in calculating my tan theta, this is what I do now. I leave the theta here and then just go tan and then negative 3/2. Now punching this into your calculator, you find your solution as negative 56.3099. So you don't really want to round off this answer. Now the negative 56 here is showing you that the angle that you are being shown there is the acute angle, but then that's not the angle that we are looking for. We are looking for this angle up here, right? We are looking for the obtuse angle in here. So what do we do? Remember, we know that this is angle on a straight line, and then since this is negative, we can achieve finding the obtuse angle by saying plus 180 degrees, right? Then which is it indicates that that's in the second quadrant, because if you can just reverse it, that's 180 minus 56.3099, which is 180 minus theta, right? And then your theta, remember you kept this answer from your calculator and then immediately you just press plus 180. So your calculator is saying answer, then plus 180. Then you find your theta as 123.7 degrees. So remember they said correct to only one decimal place, right? So 123.7 degrees, that's the theta that you find there. And then that's how you find your solution, right? So also it makes sense the fact that it is an obtuse angle. It is an obtuse angle. So an obtuse angle must always be over 90 degrees. We have a question here, the last question. This is specifically for the grade 12s. So they do not ask this question in grade 11. So at this point, if you are in grade 11, you can just leave the video because this one does not really concern you. So does C lie inside or outside the circle with center 0:0 and radius 2? Justify your answer, right? So a circle with center 0:0. So that means the circle would be here, right? Would be centered here. So the circle, we don't know how the circle is, right? So we're trying to prove whether C lies inside the circle or outside the circle. Now we know in grade 12 to prove this kind of questions, we prove them using the radius, the distance of the radius. So if we find that the distance from O to C is within the radius or it's below 2, so they're saying that the radius is equals to 2. So if we can calculate the distance from O to C, and then we actually find that the distance from O to C is less than 2, then this would mean that point C lies inside the circle. But then if we calculate the distance OC and then we find that the distance OC is greater than 2, which is greater than the length of the radius, then this would prove to us that line coordinate C lies outside the circle. So it all depends on the radius. So what we are trying to do here, let me write it. So to prove that it is inside the circle, this is what needs to happen. The OC must be less than the length of the radius. To prove that it is outside the circle, then that means the length OC has to be greater than the radius, right? So now let's get down to it. This is only for 2 marks. So we go use the distance formula for OC, and then that's x2 minus x1 square plus y2 minus y1 square, right? Then what is our x2 here? So if we are taking these ones as the second coordinates and these ones as the first coordinate, remember this is centered here on the origin, so it's 0 is to 0. So that means we only have 2 minus 0 and then square that, and then here we have a -1 minus 0, then square that. Now having to do the calculations for this one, we end up with root 5, because here we're going to have 4, and then here it's going to come out as +1. So 4 plus 1, that's root 5. Now, what is root 5? So if we simplify root 5, just SD in your calculator, then you will find that your root 5 is actually 2.236, right? Something like that, 2.236. Now, 2.236 as compared to the length of the radius, which is 2, is the distance here greater or smaller than the radius? Then obviously we can see that our distance OC, so OC is obviously greater than the radius. The 2.236 is greater than 2. So which is proving to us what? Is it outside or is it inside? Definitely it is outside, because it meets this requirement here. It meets this criteria where we said if it is outside the circle, then the distance OC has to be greater than the length of the radius. And that's how you could have taken that question there for a total of 20 marks, right? So if you are in grade 11, you were just looking at about 18 marks, excluding the last question there. But then, yeah, it's a question whereby if you now understand what needs to be done, then it was just a straightforward question. So, okay, with all that being said, guys, let's just come to the end of the video at this point. Then please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.